If we think about the derivatives we've done already, we know how to derive functions that are just trig, like cosine x or sine x. We also know how to derive polynomial functions using our basic 4 rules, or even our product or quotient rule. But how do we derive functions which are a composition? For example, the cosine of x cubed minus 5. This is not just the cosine of x, nor is it just x cubed minus 5, but rather it's the composition of the two. These functions are extremely common in the world, and yet we need to know how to derive them. The chain rule is going to do that for us. So how do we go about with the chain rule? We'll take a look at example 20 to get an idea of what happens with the chain rule. We've got 3 runners, A, B, and C. Runner A is twice as fast as runner B. Runner B 3 times as fast as C. So therefore, how many times faster is A than C? What number goes in the blank? Well, you probably are thinking and wrote down 6, and if that's the case, you would be correct. All right, how did you get that 6? Exactly, you multiplied the ratio from A to B, the ratio from B to C, to get the ratio from A to C. In other words, what you did is you said, we need the ratio, the rate of change of A with respect to C. That's what we're looking for. We don't know what that is, but we could figure it out by looking at the connection between A and B and multiplying it by the connection between B and C. And doing so allows us to get our overall answer. That's how we're going to treat the chain rule, these composite functions. If you look down at the bottom of the page, you see Leibniz notation, which looks very similar to what we just wrote down, except it's in terms of x, y, and u. Okay, I'm going to start by showing you this notation, but as you'll see, I'm going to graduate more towards this notation. This is Newton's notation, which shows more often on the AP exam. So let's go back up to the top of the page. We have our function here. All right, y is equal to the cosine of x cubed minus 5. Okay. If this was just y equals cosine of x and we had to derive it, no big deal. But it's not. It's a cosine of an inner function. Right? So we have to kind of separate this. We want to turn it from one more difficult function into 2 easier functions which we can derive. We're going to bring in a third variable besides x and y. It's that u that you see at the bottom of the screen. So here's what we're going to do. We're going to say u, that's going to be equal to x cubed minus 5. And since u is equal to x cubed minus 5, by substitution, we know that y is equal to the cosine of u. Now we have our 2 small functions. In essence, we have an outer function, the cosine of u, and then we have an inner function. The inner function is the x cubed minus 5, so u is equal to x cubed minus 5. Right? So if we derive these each, when we take the derivative of y, this will not be dy dx, because we don't have an x right here, we have a u. So it's going to be dy du. The derivative of y with respect to u. What's the derivative of cosine? Yes, it's negative sine. So we'll have negative sine u. Now over here, we're going to take the derivative of this function as well. When we derive u, we see that the independent variable is x, so we're going to get du dx. So when we derive x cubed minus 5, what's the result? That would be correct. You're looking at, I bet you wrote down 3x squared. So now if we put these two back together, right, dy dx, that's going to be equal to the product of the two. The derivative of y with respect to u times the derivative of u with respect to x. It's the exact same thing we did right over here. Okay, so what do we end up with? We have the sine of u times 3x squared. Oops, I lost my negative sign. The opposite of the sine of u times 3x squared. That's dy dx. But we have a problem here. We want the derivative of y with respect to x. This term's in respect to x, but this term is not. we don't want u in our answer. We want only x terms. So we have to go back to the top of the page. We see that u is equal to x cubed minus 5. We're going to sub the x cubed minus 5 back in. So dy dx will be the opposite of sine. And then instead of u, we have what u is equal to, which is x cubed minus 5. And we multiply that by 3x squared. Some people say, well, can we put the 3x squared, can we distribute it into this part of the function? And no, we cannot. And the reason being is that this part of the function is the extension of sine. We are taking the sine of x cubed minus 5. The 3x squared is separate from that. So we cannot distribute it in. But quite often what you will see done is the 3x squared will move up in front of the s. So we have negative 3x squared sine of the quantity x cubed minus 5. That's our derivative. So that's what we're ultimately looking to get. This cosine of this cosine of x cubed minus 5 will derive to 3x squared, negative 3x squared times the sine of x cubed minus 5. Now, sticking with this problem, I'd like to take a look at the other notation right here, chain rule. If we look at this, we have two functions. We have an outer function, which is the f, and we have an inner function, which is the g. All right. We can see, obviously, that g is the inner function because it's inside the parentheses. This derivative right here, while it looks very much different from this derivative over here, is actually the same thing. It's just different notation, as you'll see momentarily. Here's what happens. To get the derivative in this situation, we see f prime. So what do? We derive the outer function. And we keep the inner function. We don't derive it yet. And then, afterwards, we multiply by the derivative of the inner function. So derive the outer, keep the inner, then multiply that by the derivative of the inner. Let's do this with our example. So, in essence, what we have here is, I'm going to just use I'm going to use h. h of x is equal to cosine of x cubed minus 5. Cosine is the outer function. X cubed minus 5 is the inner function. When we derive this, remember down at the bottom of the page, we derive the outer function. What's the derivative of cosine? Well, it's assuming that there was an x here. Cosine of x would derive to the opposite of sine. But there's not an x here. There's something more. Right? So cosine is the outer function, and it derives to the opposite of sine. Now we keep the inner function, so the x cubed minus 5 stays where it is. And we multiply this by the derivative of the inner function. Again, I'm going to slide back down, derive the outer, keep the inner, derive the inner. That's our chain rule. Derive the outer, keep the inner, and now derive the inner. What's the derivative of x cubed minus 5? Exactly, 3x squared. We just did it. Notice that we have the same derivative in both situations. Both methods are correct. It's two different ways of looking at it. If this method, using Leibniz notation, is better for you, then use it. I'm going to steer us towards this one. It's a little quicker to do, assuming that you correctly remember, derive the outer, keep the inner, derive the inner. Additionally, this method, connected with the actual definition, what I'm boxing off right here, shows up more often on the AP exam.